Canny College is dedicated to empowering individuals to excel in their auto body trade through top-notch preparation courses for the 310B Red Seal Trade Licensing Exam. Our online course is comprehensive and designed to equip you with the skills, knowledge, and confidence needed to pass the demanding Red Seal Trade License Exam and earn your 310B Certificate of Qualification. We are your trusted pathway to success in the Canadian Red Seal Trades License Exam, a crucial milestone on your journey to a rewarding career in the skilled trades industry. Aspiring professionals seeking a Canadian Red Seal trade license can rely on our institution's expertise. Canny College offers comprehensive online exam preparation courses for various skilled trades. It uses an innovative learning approach and a commitment to excellence to equip students with the essential skills and expertise required to succeed in their chosen trades. Visit our website at www.cannycollege.com for more details. Please note that the practice questions provided here demonstrate the structure and phrasing of Red Seal examination questions. They are for study purposes only and do not result in certification or reflect actual performance on the examination. Question 1. What is done to plan for collision damage repair? A. Rough out severe damage first. B. Analyze and determine the extent of all damage. C. Determine the amount of hidden damage. D. Analyze and determine the visible damage. The correct answer is B. Analyze and determine the extent of all damage. Here are the reasons why B. Analyze and determine the extent of all damage is the correct answer. 1. Comprehensive assessment. By analyzing all aspects of the damage, including visible damage to the vehicle's exterior and internal components, as well as potential hidden damage that may not be immediately apparent, technicians can create a thorough repair plan. 2. Accuracy in planning. Understanding the full extent of the damage allows repair professionals to accurately plan for the necessary repairs, parts replacement, and repair procedures needed to restore the vehicle to its pre-accident condition. 3. Hidden damage. Hidden damage, such as structural issues or internal damage that may not be immediately visible, can significantly impact the safety and performance of the vehicle if left unrepaired. Identifying and addressing hidden damage is crucial for ensuring a complete and safe repair. 4. Cost estimation. A detailed analysis of all damage helps provide an accurate cost estimate for the repair work, including labor, parts, and any additional services required. This allows customers and insurance providers to understand the repair's scope. In summary, analyzing and determining the extent of all damage is a crucial step in planning for collision damage repair to ensure a thorough, accurate, and safe repair process. Question 2. An electrical fuse blows repeatedly. What is the cause? A. An open circuit. B. A closed circuit. C. Insufficient amperage. D. A short to ground. The correct answer is D. A short to ground. When an electrical fuse blows repeatedly, the most likely cause is a short to ground. Here are the reasons why. 1. Short to ground. A short circuit occurs when a wire or component comes into contact with a ground or metal surface. This creates a path of low resistance, causing an excessive flow of current that can lead to the fuse blowing to prevent damage or a potential fire hazard. 2. Repeated blowing. If a fuse continues to blow repeatedly, it indicates that the short to ground is persistent and causing the circuit to overload, triggering the fuse to blow each time power is supplied. 3. Troubleshooting. To address the issue of a repeated blown fuse, the short circuit causing the excessive current flow needs to be identified and isolated. Once the short to ground is located and repaired, the fuse should no longer blow, restoring proper operation of the electrical circuit. In summary, when an electrical fuse continues to blow repeatedly, the likely cause is a short to ground in the circuit. Identifying and resolving the short circuit is essential to prevent further damage to the electrical system and ensure safe and reliable operation. Question 3. When replacing a front frame rail on a unibody vehicle, where is it sectioned? A. In the center of a crush zone. B. At a suspension mounting point. C. At a dimensional reference hole. D. In front of a suspension mounting point. The correct answer is D. In front of a suspension mounting point. When replacing a front frame rail on a unibody vehicle, it is typically sectioned in front of a suspension mounting point. Here are the reasons why. 1. Structural integrity. The front frame rail is a critical structural component of a unibody vehicle that provides support and rigidity to the front end of the vehicle. By sectioning the frame rail in front of a suspension mounting point, the structural integrity of the suspension attachment is maintained. 2. Suspension geometry. Sectioning the front frame rail in front of a suspension mounting point ensures that the suspension geometry and alignment remain consistent after the repair. This is crucial for maintaining proper handling, steering, and performance characteristics of the vehicle. 3. Transfer of loads. By sectioning the front frame rail in front of a suspension mounting point, the loads and forces transmitted from the suspension components to the frame rail are properly distributed and transferred, ensuring the stability and safety of the vehicle. 4. Repair considerations. Sectioning the front frame rail in front of a suspension mounting point provides a logical and strategic location to perform the repair, facilitating access to the damaged area and allowing for accurate alignment during the replacement process. In summary, when replacing a front frame rail on a unibody vehicle, sectioning it in front of a suspension mounting point helps maintain structural integrity, suspension geometry, and load transfer, and facilitates the repair process. Question 4. When using a metal patch to repair a rusted area, what is done to help maintain the original contour and minimize distortion of the panel? A. Remove rusted area, shape patch to fit for lap joint, then weld. B. Remove rusted area, shape patch to fit for butt joint, then weld. C. Remove rusted area, flange the panel, shape patch to fit for butt joint, then weld. D. Remove rusted area, flange the panel, shape patch to fit for lap joint, then weld. The correct answer is D. Remove rusted area, flange the panel, shape patch to fit for lap joint, then weld. When using a metal patch to repair a rusted area and aiming to maintain the original contour and minimize distortion of the panel, the correct process involves removing the rusted area, flanging the panel, shaping the patch to fit a lap joint, and then welding it in place. Here are the reasons why this process is the correct approach. 1. Removing the rusted area. By cutting out and removing the rusted area entirely, you ensure that the repair area is clean and free of corrosion. 2. Flanging the panel. Flanging involves creating a raised edge or lip along the perimeter of the repair area. This provides a surface for the patch to rest on and helps maintain the original contour of the panel. 3. Shaping the patch for a lap joint. Shaping the patch to fit a lap joint involves overlapping the patch onto the flanged edge of the panel. This joint configuration adds strength to the repair and helps minimize distortion by distributing the load more evenly. 4. Welding the patch in place. The patch is then welded onto the flanged area using the lap joint configuration. Proper welding techniques help secure the patch in place and ensure a durable repair while minimizing panel distortion. By following this process of removal, flanging, shaping for a lap joint, and welding, you can repair a rusted area with a metal patch while maintaining the original contours of the panel and minimizing distortion. Question 5. What is done to determine if a door opening has been distorted in a collision? A. Create an outline template using cardboard. B. Compare left and right doors. C. Check the freedom of movement of the glass in the window opening. D. Make a series of measurements from points in the opening. The correct answer is D. Make a series of measurements from points in the opening. When assessing whether a door opening has been distorted in a collision, the correct approach is to make a series of measurements from various points in the opening. Here are the reasons why. 1. Measurement accuracy. Taking measurements from different points in the door opening allows for a detailed assessment of any potential distortions or misalignments. By comparing measurements across the opening, you can identify any discrepancies that indicate distortion. 2. Evaluation of symmetry. Measuring key points in the door opening helps assess the symmetry and alignment of the opening. Any deviations in measurements from side to side can indicate distortion or misalignment resulting from the collision. 3. Structural integrity. By measuring critical points such as diagonals and specific locations in the door opening, you can determine if the structural integrity of the frame has been compromised or if any deformations need to be corrected. 4. Data-driven analysis. Making precise measurements provides objective data to assess the extent of any distortion and guide the repair process effectively. This data helps ensure that any necessary corrective actions are taken to restore the door opening to its original condition. In summary, Making a series of measurements from points in the door opening is a methodical and accurate way to determine if distortion has occurred as a result of a collision. This approach provides the information needed to assess the damage and plan for the proper repair of the door opening. Question 6. What is the procedure to remove a door trim panel to access a power window regulator? A. Remove trim panel, peel back vapor barrier, then detach glass. B. Remove trim panel, detach glass, then peel back vapor barrier. C. Release fastener covers and fasteners. Partially remove trim panel. Disconnect electrical, then remove vapor barrier. D. Release fastener covers and fasteners. Remove trim panel, disconnect electrical, then remove vapor barrier. The correct answer is D. Release fastener covers and fasteners. Remove trim panel, disconnect electrical, then remove vapor barrier. When removing a door trim panel to access a power window regulator, the correct procedure typically involves the following steps. D. Release fastener covers and fasteners, remove trim panel, disconnect electrical, then remove vapor barrier. Here is why this answer is correct. 1. Release fastener covers and fasteners. Start by identifying and removing any fastener covers or visible fasteners holding the trim panel in place. These are often located around the edges of the trim panel and may be hidden behind covers or trim pieces. 2. Remove trim panel. Once the fasteners are released, carefully detach the trim panel from the door frame. The trim panel typically snaps into place with clips or hooks, so gentle pressure may be needed to release them. 3. Disconnect electrical. If the trim panel contains electrical components, such as power window switches or door locks, disconnect these electrical connections to fully remove the trim panel without damaging the wiring. 4. Remove vapor barrier. After the trim panel is removed, the vapor barrier, a protective moisture barrier inside the door, may need to be removed to access the internal components of the door, including the power window regulator. Following these steps helps ensure that the door trim panel is removed correctly and safely, allowing access to the power window regulator for inspection or repair. Question 7. Which type of adhesive is used when installing a heated windshield? A non-conductive urethane. B. Polyurethane. C. Non-conductive silicone. D. Butyl tape. The correct answer is A. Non-conductive urethane. Here are the reasons why. 1. Non-conductive properties. Non-conductive urethane adhesives are specifically designed for use in applications where electrical conductivity can be a concern, such as with heated windshields. Using a non-conductive adhesive helps to prevent interference with the electrical components of the heated windshield system. 2. Flexibility and durability. Urethane adhesives offer flexibility and durability, allowing them to withstand the stresses and strains that windshields encounter during vehicle operation. This ensures a strong and long-lasting bond between the windshield and the vehicle. 3. Sealing properties. Urethane adhesives have excellent sealing properties, helping to prevent water intrusion and maintain the integrity of the windshield installation. This is crucial for protecting the interior of the vehicle and ensuring a secure fit. 4. Compatibility with heating elements. Non-conductive urethane adhesives are compatible with the heating elements embedded in heated windshields. They provide a reliable bond that allows for the proper operation of the windshield heating system without interference. Overall, using non-conductive urethane adhesive when installing a heated windshield helps ensure a successful installation that maintains electrical integrity, provides a strong bond, and supports the optimal performance of the windshield heating system. Question 8. What is done before going under a vehicle that has been raised with a floor jack? A. Support the vehicle with jack stands. B. Remove the wheels from the vehicle. C. Ensure the floor jack is in the locked position. D. Support the vehicle with wood blocks. The correct answer is A. Support the vehicle with jack stands. Here are the reasons why using jack stands is crucial for safety when working under a raised vehicle. 1. Stability. Jack stands to provide a stable and secure support system that helps prevent the vehicle from falling or shifting while you are under it. This ensures a safer work environment and reduces the risk of accidents. 2. Added protection. Floor jacks are hydraulic devices that can fail or lose pressure over time, potentially causing the vehicle to drop suddenly. Jack stands to act as an additional safety measure to support the vehicle in case of a jack failure. 3. Locking feature. Unlike floor jacks, jack stands are designed with locking mechanisms that keep them securely in place at the desired height, providing reliable and fixed support for the vehicle. 4. Height adjustment. Jack stands can be adjusted to different heights, allowing for specific positioning to support the vehicle safely and at the correct height for the work being performed. In summary, before going under a vehicle that has been raised with a floor jack, it is essential to support the vehicle with jack stands to ensure a secure and stable working environment and reduce the risk of accidents or injury. Question 9. A unibody vehicle is hit on the front right corner, causing inner structural damage. What is done to diagnose the extent of secondary damage? A. Mount a set of centering gauges. B. Perform a 3D measurement. C. Use a tape and tram gauge to measure. D. Compare side-to-side measurements. The correct answer is B. Perform a 3D measurement. Here are the reasons why a 3D measurement is the correct approach. 1. Comprehensive assessment. 3D measurement techniques allow for a thorough and precise assessment of the vehicle's frame and structural components in three-dimensional space. This method provides detailed information about any deviations, deformations, or misalignments caused by the impact. 2. Detection of hidden damage. A 3D measurement can reveal hidden or subtle damages that may not be immediately visible or apparent. It helps identify secondary damage beyond the initial impact site, allowing for a comprehensive diagnosis and repair plan. 3. Accuracy and precision. 3D measurement tools and technology offer high levels of accuracy and precision, providing detailed data points that assist in understanding the full scope of structural damage. This data is crucial for making informed decisions on repair strategies. 4. Alignment verification. By performing a 3D measurement, technicians can verify the alignment of vehicle components, including frame rails, suspension mounts, and other critical areas. This ensures that the vehicle is restored to its original specifications. In summary, performing a 3D measurement is a sophisticated and effective method to diagnose the extent of secondary damage on a unibody vehicle, particularly after a significant impact on the front right corner. This approach provides detailed information essential for planning and executing accurate and comprehensive repairs. Question 10. What is the procedure to reinstall a body side molding after removal and repair? A. Remove old adhesive. Apply urethane adhesive, clean surface, then reinstall molding. B. Remove old adhesive. Apply adhesion promoter to molding. Apply new adhesive, then reinstall molding. C. Remove old adhesive. Apply adhesion promoter to panel. Apply new adhesive, then reinstall molding. D. Remove old adhesive, clean surface. Apply new adhesive, then reinstall molding. The correct answer is B. Remove old adhesive, apply adhesion promoter to molding, apply new adhesive, then reinstall molding. Here is why this sequence is the correct approach. 1. Remove old adhesive. Start by thoroughly removing any old adhesive residue from both the vehicle panel and the molding to ensure proper adhesion of the new adhesive. 2. Apply adhesion promoter to the molding. Using an adhesion promoter on the molding helps enhance the bonding process and ensures that the new adhesive adheres effectively to the surface of the molding. 3. Apply new adhesive. Apply a suitable new adhesive to the molding, following the manufacturer's instructions for the type of adhesive being used. This step is crucial to ensure a strong and lasting bond between the molding and the vehicle panel. 4. Reinstall the molding. Carefully position and press the molding into place on the vehicle panel, taking care to align it properly. Ensure that the adhesive has adequate contact and allow it to set and cure according to the adhesive manufacturer's recommendations. By following these steps, you can effectively reinstall a body side molding after removal and repair, ensuring a secure and durable bond between the molding and the vehicle panel.